In this episode of Speaking of Chemistry, we're going to find out just how bad my sweat smells. And we'll get to that soon enough. But where our story actually starts is with a bandage that fights bacterial infections. With electricity. Maybe. This bandage, sold as Prosolera, looks and feels like a regular cloth bandage, but it costs a little more, presumably because of its electrical powers. A box of 3 bandages like this goes for about $48 a pop. The bandage is covered with little zinc and silver dots. When moistened with an electrolyte, fluid from a wound for example, contact with the dots creates a small voltage, allowing electrons to flow from zinc anodes to silver cathodes. Early batteries used the same idea. Those were made of 2 different plates, like zinc and copper, stacked on top of one another. Sandwiched between each plate was cloth or paper soaked with an electrolyte. Basic battery design is what inspired Jeff Skiba when he invented the bandage prototype 10 years ago.
And so I thought, what if I took the battery apart in 3 dimensions and then I laid it on a flat surface?
And recently, studies have shown that the electric bandage can kill bacteria that infect wounds. How exactly it does that is up for debate. But however it happens, keeping bacteria away from wounds is what you want.
Wound healing and treating the infection, they go hand in hand. Control of the bad bugs in that wound site is critical to have an improved wound healing, to have less scarring, and to have a better patient outcome.
That's Mina Izaju. She works in the private sector now, but for more than a decade, she researched wound care technology, including Prosolera, for the military. She's also served as a consultant for Vomaris, which makes the bandage. Izaju says the beauty of the bandage is that 1, it doesn't need an external power source, and 2, it offers doctors another way to treat infections, which can be deadly as bacteria have developed resistance to drugs. The CDC reports more than 23,000 annual deaths in the US from antibiotic-resistant infections. Working with Vomaris in 2014, Izaju's lab isolated drug-resistant strains of bacteria from the wounds of military personnel. The electric bandage stopped these microbes from growing or killed them outright. Last year, Chen and his group at Ohio State University showed the bandage also prevents biofilm bacterial infections in lab animals. Biofilms are like gooey shields that bacteria come together to make. Bacteria in these films are notoriously resistant to antibiotic drugs. Biofilms also cling to surfaces, which can lead to really resilient infections when those surfaces are things like bed sores or embedded medical devices. So how does this bandage bust up biofilms and other bacterial infections? Findings from C&EN's lab suggest that the electric field does 2 things. For 1, it activates oxygen and turns it into a bacteria-blasting missile. For another, it disrupts the signals that bacteria send to each other that say, hey, let's build a biofilm. We should note that some of these studies were partly funded by Vomaris. We also asked C&EN about a potential wrinkle. Silver by itself is used as an antibiotic in a number of products today. So what if it's just the silver dots that are doing all the work? C&EN says that's not the case. His lab ran control experiments in which they treated a biofilm with 3 separate bandages. 1 placebo, 1 with silver and zinc, and 1 with just silver. Only the bandage with silver and zinc effectively killed the bacteria. I talked to biochemist Vincent Rotella of the University of Massachusetts Amherst, who still wasn't completely convinced about the mechanism. Rotella suggests 2 more control experiments that would help rule out the metals acting on their own. One is to switch out the silver dots for another metal like gold. Another is to test the bandage with just zinc dots. I asked Izaju what she thought of the mechanism, and she says it might be silver and the electric current's powers combined that's killing the bacteria. So far, we've seen petri dish and animal studies with these electric bandages. But what about its effectiveness in people? Soon, a clinical trial at the San Antonio Military Medical Center will test the product's efficacy at treating patient burns. But doctors are already using the product to try to fight antibiotic-resistant infections, particularly in sports medicine. The bandage makers think their product could also help athletes' performance and have incorporated the silver and zinc pattern into sportswear. Vomaris is conducting studies of the shirts with endurance athletes. In one small study, Vomaris was surprised to find that 90% of the athletes felt odor-free or less smelly than usual after working out in the shirts. CEO Michael Nagel attributes this to the material's ability to kill odor-causing bacteria. That sounded pretty incredible, so I couldn't help but ask. Is it possible to get a t-shirt for our video?
Yeah, I think I'll look and see if we've got an extra one to send you, absolutely.
So here we are. To see for ourselves whether the electroactive shirt actually works, we had to figure out just how bad I smell. First, as a control, I worked out wearing a normal shirt with a similar texture. Then the next day, I did the same thing with the fancy electroactive shirt. It took me about 25 minutes both times to get this sweaty. Then we found some brave souls for a subjective smell test. You guys, smell anything?
Should I smell something?
We waited a few hours post-workout to give the odor-producing bacteria time to proliferate. Then, my very dedicated Speaking of Chem co-host rated the smell of both shirts on a point scale, where 0 is neutral, 10 smells like a delicious meal, and -10 is rotten fish. First up, the control shirt. It scored a -3 from Carrie and a -4 from Manny. They described the smell as similar to sour milk. Now the moment of truth. The electric shirt came in at -2.5 from Carrie and 0 from Manny. He said it just smelled like a normal shirt. So there you have it, folks. The marginally satisfying results of an off-the-cuff, so not blinded experiment. Special thanks go to Sarah Everts, the sage of sweat science, for her insights on the smell test, and of course to Vomaris for giving us the shirt, which we've washed and will be donating to Goodwill. And thanks to you for watching. For more experimental adventures with Speaking of Chem, be sure to subscribe to our YouTube channel.
No.